welcome back. So we are on our final lesson. So we're looking at 3.10. So what we're looking at here is we're reducing the expressions to the lowest terms. So if we look, I'm going to make this a little bigger to make this easier. So if we look at number 1, we have an x in the numerator and we have an x squared in the denominator. So the x and the x squared are going to cancel each other out. So now we're left with 3 over 6x. Now, 3 and 6, they're both divisible by 3. So divide that by 3, we get 1. Divide 6 by 3, we get 2. So we end up with 1 over 2x when we simplify it down. Now, if we look at number 5, we have 3x minus 5 times x plus 4 over x minus 1 times 3x minus 5. We've got that 3x minus 5 and the 3x minus 5. One in the numerator, one in the denominator, they cancel. So our answer is just x plus 4 over x minus 1. That's what you're looking at doing for this section. All right, the next section, reviewing features of polynomials. Some information has been given for each polynomial. Fill in the missing information. So we have the function f of x equals, f of x equals x to the third. So the function in factored form is going to be f of x equals x times x times x, because x to the third is just x multiplied to itself 3 times. So its end behavior, as x goes to negative infinity, f of x goes to negative infinity. And as x goes to positive infinity, f of x goes to positive infinity. The roots. So the only roots that f of x equals x to the third is going to have is x equals 0. Remember, roots are the same thing as zeros. So where does our y value equal 0? All right, the degree, remember the degree is the exponent. So degree is 3. And the value of the leading coefficient is always on your variable with the largest exponent. We only have one variable here with an exponent, so leading coefficient is the number out in front. In this case, it is 1. So now we need to take and graph this. I'm going to attempt to draw my axes. Kind of, sort of. Okay, so there we have our axes. Now, a cubic function. Oops. It's going to be really rough trying to draw this. Looks something like so. So that's what it's going to look when you have a cubic function. Okay? All right. For 11, you're going to have to take and multiply through to figure out what your degree is. So you're going to have to FOIL these two and then multiply everything by a negative x. Then you'll graph it out. Pardon me. Figure out your end behavior and its roots. The roots are pretty easy just looking at it. We've got 0, we've got positive 2, and we've got positive 4. Those are your roots. So equal x. Degree you'll have to take and figure out. And leading coefficient, once you multiply all this through, you'll figure that out. But these are your 3 roots. So that means your graph is going to cross the x-axis 3 different times. So keep that in mind. This one is already in standard form for you. Degree is 3. This one wants to know the value of h of 2. So that means you're going to plug 2 into the equation. So 2 to the third power is 8. 2 squared is 4, but 4 times 2 is 8. So we have 8 minus 8, so that just goes away. And then 2 times 3 is 6, so we have 8 minus 8, which is 0, minus 6, so we end up with negative 6 there. Once you take and factor this, you'll be able to find your roots. I will tell you there are 3 of them. All right, here we have the graph of a function. So because we have 1, 2, 3, 4 places where there are zeros. That means it is a fourth exponent, so it's 4 degrees. Our y-intercept is just 0. 0 is also one of our roots. Another root is at -2. We've got another one at 1 and another one at 2. As x goes to -infinity, f of x goes to positive infinity. As x goes to positive infinity, it's also going to positive infinity. Remember, on the even numbered functions, it's always going to go to infinity. On odd number for both, or either both go to positive infinity or both go to negative infinity, or on odd ones, they're going to go opposites. Okay, so function x to the 4th minus x to the 3rd minus 4x squared plus 4x. And then the factored form of this, I'll let you work out. Use factor by grouping to take and group this and simplify it down, okay? So you still have to figure out this right here, okay? All right, you have another one. Another one you have to graph. Okay, 16 and 17. You want to finish the graph if it's an even function and if it's an odd function, okay? So you should be able to do each of those. All right. You're going to write the polynomial function in standard form given the leading coefficient and the zeros of the function. I'm not going to make you do this section, okay? So you get free points for it. I'm going to give you the credit for doing it, but you do not have to take and do that. It's going to be a little complicated to explain over the computer. So you do not have to do those. The last section, though, you are going to fill in the blanks to make a true statement. So if f of b equals 0, then a factor of f of b must be 0. The rate of change in a linear function is always a constant amount. So then you're going to take and look at the rate of change in a quadratic function, the rate of change in a cubic function, and the rate of change in a polynomial function of degree n can be described by a function of degree n something. So basically, with our rate of changes of different functions, a linear function has a degree of 1, but its rate of change is a constant amount, so a degree of 0. So the rate of change of a quadratic function, we go 1 degree down. Quadratic is squared, so 1 down from that would make it linear. So I'll let you finish out the last two. Remember, you don't have to do this section right here. Your keyword for this lesson is function. Your keyword is function. Have a wonderful week and happy mathing. And also have a wonderful summer. Bye.